So as we definitely know these days, we got pathogens out there that can come in and cause havoc in our bodies, cause homeostasis to go out of whack. And so that is basically the job of the immune system, okay, is to fight off those pathogens, to get rid of them and neutralize them, and then get rid of them out of the body. And so this is definitely one that hits home since we're spending our days at home now and doing this class online because of one certain pathogen. Okay, but the immune system is what is the component, the system that is going to go through and neutralize and basically get rid of those pathogens. Okay, so we're going to go over the different components. We'll look at the anatomy, spend some time on the different structures. We'll spend a decent amount of time on the white blood cells because those are the chief cells that operate to make the immune system run. Okay, so let's first look at the major components. There are three major components. We got physical barriers. All right, so first line of defense is let's keep the pathogen out. And so that's what our skin and our mucous membranes are basically coverings that give us physical barriers. The lymphoid tissue, you guys have probably learned in anatomy, the bone marrow, thymus, spleen, lymph nodes, so forth. All right, they help, and one of their main functions is development of the leukocytes. Okay, and that's the third component. So leukocytes are the white blood cells. Okay, those are the chief cells that are going to run the immune system. Okay, give us a wide range of a response, and we'll spend a good amount of time talking about the actions of these cells. All right, so looking at the physical barriers, we got the skin, right, the epidermis and dermis. That's looking here, very thick layer. So this is a good form of a barrier. We also have the mucous or membranes. Okay, they are many times ciliated because they produce the mucus. Okay, they are a thinner layer though, so they have a fairly rich blood supply. So these are a little more delicate than say the skin. So these are what line the nasal cavities, the digestive tract. So this is why you shouldn't be putting your hands around these areas because these mucous membranes aren't as protective as say the skin is. Okay, you can get foreign pathogens in, but it does do a physical barrier. Also, along with the physical barrier, we have stuff like acidity. The acidity of the stomach is a good means of highly acidic environment. Many bacteria and so forth can't survive in these environments, so this is also a form of a physical barrier for the system. Next up is lymphoid tissue. Okay, the lymphatic system. This is where we have central lymphoid tissue. That's going to include the bone marrow and the thymus. Okay, and then we're going to have some peripheral lymphoid tissue. We'll look in just a second, but let's first look at the central lymphoid tissue. Okay, the bone marrow. What's its job? Basically, the bone marrow, this is what's taking place in the bone marrow. All of the cells of the blood are made in the bone marrow. We have a stem cell, and all the, you can see the bone or the blood cells, okay, meaning that make up the immune system, and the red blood cells, these are all made in the bone marrow. Okay, so the bone marrow is central because it's making the cells that are actually going to operate the immune system. Okay, those leukocytes. The thymus. Okay, thymus sits here. It's a gland. Okay, and it's basically, we're going to talk about a cell, T lymphocytes is one of the leukocytes, and many of the cells get released from the bone marrow mature, but the T lymphocytes actually go to the thymus, and this is where they reach maturity. It's kind of like their boot camp. Okay, the T lymphocytes, we'll talk about them in a bit, but this is where they come to get trained to operate the way they need to do. This is where they reach maturity. So peripheral lymphoid tissue, okay, spleen and lymph nodes, and the major players here. Okay, we also have tonsils, okay, adenoids and appendix and Peyer's patch. These are all lymphatic tissues, and usually they are areas in which there is collection of leukocytes. Okay. Usually they are areas in which you can trap microorganisms or foreign particles. The pathogens can get trapped, and since we have immune cells there, we can start an immune response. Okay. So we can get high concentrations of the pathogens. Okay, and basically here's looking at a lymph node. Here's looking at the microstructure of the spleen. They're kind of like nets. They're nets as the blood comes in there and gets filtered out, and you kind of almost like a net to catch the pathogens, and that's key because what is there? Those immune cells are there to start the immune response. So this is kind of how the peripheral tissue, lymphoid tissue works. We're going to trap the organisms or giving access of the pathogens to the B, T cells and macrophages, those immune cells, so they can start the immune response. All right, so let's look at the main players. Okay, the leukocytes or the white blood cells. This is probably something you've seen in anatomy, but we have two major classes of white blood cells, and it basically they're graded or classified on whether you see granules or not, if they're granulated. Okay, granulocytes have visible granules. These two you can see pretty closely, the visible granules, the basophils, a little bit harder. Okay, but these are granulocytes. The other classic characteristic of the granulocytes are these lobed nuclei, and usually there are multiple. So polymorphonuclear is the name they are given. Okay, but the cells, neutrophil, eosinophils, and basophils. The other class is the agranulocytes. Okay, so no visible granules here. And two cells, we got lymphocytes. We're going to see there are different types of lymphocytes, okay, but there's no granules here. Lymphocytes are kind of easy to classify because they have this big nucleus with very little cytoplasm. Okay, the monocytes, the largest of the bunch, okay, they have this big kidney bean-shaped nuclei, okay, and no visible granules like you see up in here. So let's look at kind of the basic functions of these. We'll spend a little bit of time on these. We're going to spend a good amount of time on the lymphocytes because these are some of the main players in the immune system and the immune response. Okay. All right, so the granulocytes, one of the main players in the immune system are the neutrophils. You can see they are very abundant. Forgot to mention, in the blood, basically these white blood cells only make up about 1% of the actual blood, but the biggest component of that 1% is these neutrophils. Okay, they're kind of the frontline defense of the immune system, the white blood cells. Okay, they act as phagocytes. Okay, they are phagocytic. Phagocytic meaning they're kind of like the Pac-Mans. They go around and eat bacteria. They find foreign pathogens, and they will engulf them and basically digest them. So that's what phagocytes do. Neutrophils are the main players. They are phagocytic. Okay. Eosinophils also act as phagocytes. Okay, so they engulf certain pathogens when they see them, but one of their main functions is they have the granules, and these granules are filled with chemicals, usually chemicals that go in will attack or lyse that pathogen. For the eosinophils, their main targets are parasites in the body. They are antiparasitics. Okay. The basophils, okay, and we saw eosinophils are only about 2 to 4%, so not a ton of these, and even less is basophils, from 1% or even below. But their main function, basophils are not phagocytic, so they don't engulf bacteria. Their main function is release of histamine and inflammation for allergic response. We'll see this part in just a bit, inflammation, one of the big components of an immune response. All right, so then we get the granulocytes. Okay, about 3 to 8% of the white blood cells are monocytes. Okay, these are phagocytic. They can become macrophages, which are phagocytic cells that are in the tissue. Okay, and they go around in the blood. They can phagocytose in the blood, but they can also undergo diapetes. Diapetes is the movement of the white blood cell out into the tissue. Basically, they squeeze through the endothelium to get to the site of infection. Okay, and once they're there, they become macrophages and be phagocytic and basically engulf whatever it is and digest it up. And then the other granulocytes, this is the one we'll spend a good amount of time on, are the lymphocytes. Okay, 20 to 25% white blood cells. And these are made up of three categories. Okay, we got the B lymphocytes, T lymphocytes, and we'll see there are also null cells. Okay, but these are kind of the big players in what we call the adaptive immunity or specific immunity. Okay, and we'll see there's one other player, the natural killer null cells, where most are natural killer cells, which we'll see about in just a second. Okay, but the big players in the lymphocytes are the B and the T lymphocytes. So many of the white blood cells act as phagocytes. Okay, and a phagocyte is basically almost like a Pac-Man. They will, when they come across a pathogen, they will form these pseudopodias. These pseudopodias wrap around the pathogen, okay, ultimately engulfing them and containing them in a vesicle. These phagocytes typically have other vesicles that will merge that have enzymes that can break down these components, break down whatever pathogens are. Okay, so phagocytes, cells that make phagocytes throughout the body, those abundant neutrophils, leukocytes, those eosinophils, monocytes. Okay, and then there are macrophages. These are resident in the tissue phagocytes. Okay, because typically these cells are running throughout the blood and then get recruited to migrate to the tissue when there are infections. Okay. So their main job, and then there are also dendritic cells, but their main job is to engulf that pathogen. Okay. Also, when they come across pathogens, many times they secrete cytokines. Cytokines are chemicals. You may have heard these in the news just recently, because many of the younger folk, they believe, is coming across cytokine storm. The coronavirus is inducing their immune system to go almost like haywire, and secreting these chemicals are good because they basically can cause inflammation. They can recruit other immune cells to the site. Okay, so it's good. They have a function because they help increase the immune response, but in too much, an overabundance can cause havoc on the body. And so that's, you may hear in the news, cytokine storms, and these are chemicals that are released by many of these immune cells. Okay, cytokine storm just means there is an overabundance, and it almost makes the immune response almost too robust, too strong. Okay, and the immune system's going in and attacking cells and causing haywire in the body. Okay. Right. The one we're going to spend the most amount of time on are going to be those lymphocytes, because these are the cells that you're hearing about the components most in the news, and these are kind of the main big players in the immune response. Okay, coordinated immune response. There are 3 different types of lymphocytes. Okay, make up 20%, 20 to 40%, depending on what's happening. Typically, that would be more if there is a infection and so forth. But 3 types. We got the B lymphocytes. Okay, they're going to participate in humoral immunity, which we'll talk about. The T lymphocytes, they participate in cellular immunity. And then these NK. NK stands for natural killer cells. Okay, and these are virus-infected cells. Okay, and we're going to see the difference between these bunch, and also kind of the way they respond to an infection and what their response is. Okay, so we'll be spending majority of our time looking at the functions and activities of the lymphocytes. Okay, the first of those lymphocytes are the B cells, the B lymphocytes. These are the ones you've heard produce the antibodies. Okay, you can see here's a B lymphocyte. They have receptors. Okay, and these receptors are specific for a certain pathogen. Okay, when they come in contact with those pathogens, they will start making antibodies associated with that pathogen. Okay, you've probably heard in the news the antibody test, the serological test. And that is because these antibodies aren't produced unless a certain pathogen is seen by the B lymphocyte. So these antibodies would not be produced unless the immune system, these B lymphocytes, have seen that certain pathogen. So that's what they're trying to get up for the testing, is testing for the antibodies, or testing to see whether somebody was infected by, in our case, coronavirus, what we're talking about these days. Okay, if they have the antibodies that are specific to the coronavirus, then we can assume that they had an infection with coronavirus. And again, as you've heard in the news, many people have had the virus and haven't even known they had it. Thought they might have had a cold or had very few symptoms, if at all. But the fact that they have the antibodies means that they have had the infection and their immune system has seen that coronavirus. Okay, so their main function basically is to secrete antibodies. All right, we'll see antibodies mark invaders, mark pathogens for destruction. They also, we will see, have several other functions when coming in contact with pathogens. Okay, but B lymphocytes making the antibodies. The T lymphocytes, okay, they are actually going to go. Okay, there are 3 different types. We'll talk about them in a bit, but basically their job is to basically go after the cells. So those viruses, they go in and they take over the machinery of the cells and start replicating. So, one copy becomes thousands of copies, and these are the ones, the T cells go in to neutralize the cells. They will go in and destroy the infected cells. Okay, so then the virus has no cell, because we'll see the viruses need to have a host to multiply to cause their damage, and if we kill off the cell, then the virus can't use that cell as a host. Okay, so we'll talk about these guys too. So we're going to, like I said, we're going to spend most of our time talking about the actions of the lymphocytes, and we'll see the T lymphocytes. Okay, these are talked about cell-mediated immunity, because what are they doing? They're going and actually attacking the infected cells. The last is the null cells. Okay, the null cells, most of them are those NK cells, those natural killer cells. Okay, and they are important defense for viral infection. So they are kind of like the first line of defense. Okay, they are called part of the what we call innate or non-specific immune response. Okay, and they will go attack, just like the T cells, they attack virus infected cells. They operate in a different way than those T lymphocytes. We'll see. Okay, they are non-specific, where the T lymphocytes are specific, but they act in a similar manner, and they are going to go and find the infected cells and basically cause destruction and lysing of those cells. Okay, they are very fast acting, so they are one of the first players of the immune response in the beginning steps of the immune response. Alright, so let's see why we have these immune cells. What are we going after? These pathogens that activate the immune response. Okay. The one we've most notable now is viruses. Right? Since we are dealing with coronavirus, this is essentially what a coronavirus is there is nucleic acid, okay, with this protein capsule. It has this rod and tail, but the essential function is these viruses, they must have a host, they must have a cell to be able to be viable. And so what they do is they gain access once they're in the bloodstream, once they get into the body, okay, they gain access to cells of the body. Okay? In this case, for coronavirus, this virus will gain access into cells of the respiratory tract. And what they do is they basically hijack the metabolic machinery of the cell and use that machinery to basically replicate more and more and more of these viruses. So basically you start with this one virus and turn into thousands of these virus molecules. Okay, you have these virus molecules and you have thousands of them. Eventually there's so many that the cell lyses, and what happens? All these thousands of virus molecules go out into the tissue and can infect more cells and start the process all over again. Okay, so that is what the virus is doing. They are going in, hijacking the machinery of the cell, and basically making more and more copies of the virus. Okay, the other one you commonly probably know about, bacterium. Okay, they go in and invade tissue. Besides invading the tissue, the bacteria can also release toxins that can cause problems with the surrounding tissue and throughout the body. Okay, so they call endotoxin or exotoxins. They can get released by the bacteria, so they invade the tissue and also release those toxins. Funguses. Okay, funguses are common one, athlete's foot, okay, or jock itch, yeast infection. All right, and there are some fungal infections of the lungs, but probably the more common, but typically linings. Okay, they typically multiply on the linings, but can gain access and take over. Okay. Parasites, parasitics, okay. They invade the host and they use the host and obtain nutrients. Okay. Sometimes they use up so much of the nutrients that the cells don't get the nutrients. Some of the common tapeworm. Okay. Tapeworms live in the digestive tract basically, and they hijack and live off the nutrients from those cells. Okay, but those are the common pathogens in which this immune system is there to basically get rid of, to neutralize and to get rid of it out of the body. So there are two kind of defenses that make up the immune response. The first, or the initial defense, is called the innate defenses. Okay, non-specific or innate. So these defenses are non-specific. So any pathogen would activate this innate defense. So it is not a specific, not a coronavirus or poliovirus, so forth. It is not a specific virus or pathogen that elicits. Innate is any pathogen. Okay, so that's why it's called non-specific. Defends us against potentially harmful substances. What makes up the innate is those physical barriers. Inflammation, we're going to talk about inflammation, interference and complement. We're going to lay off of those a bit, but then the cells, those phagocytes are non-specific. They don't go after a specific organism or pathogen. They will go after and try to Pac-Man up any pathogen they deem as foreign to the body. Okay, so non-specific is basically this first line of defense. If this first line of defense doesn't work, anytime like coronavirus, this first line of defense isn't going to get rid of it. That is when the specific immune response takes place. We get the adaptive immunity. Okay, adaptive immunity is elicited by the lymphocytes. Remember, we have those B and T lymphocytes. Okay, this defense is, just as we say, specific immune response. So it is specific to a certain pathogen. You have B and C cells that are going to be specifically fighting against coronavirus. That's going to be their target. Where these cells here, any foreign body, they're going after. These cells, these B and T cells, are going to fight specifically against, there's going to be B and T cells that are specifically there to go against coronavirus, or there are some that are specific to go against poliovirus. Okay, so this defense is specific for the pathogen. So one process of the non-specific immune response, we'll look at just a couple. We saw the interferon, inflammation, interferon, complement system. Also, natural killer cells are part of this non-specific or innate immune response, but want to focus on one, inflammation process in its regards to starting the immune response, or what its function is. Okay, so we're going to look at inflammation. Basically, there are 5 series of events. Okay, so if you get a cut, right, you get a cut, you don't clean it out, there's some pathogens in there, some bacteria that gets in and starting an infection. Okay, what usually happens? What usually do you look for if you have an infection on, say, your cut? You're looking for redness. It gets hot, so forth. You get this inflammation response that you're looking for. Okay, and what's taking place during this inflammation? Firstly, there are macrophages, those immune cells that are out in the tissue. They would be out underneath the skin, right? That are out there, and once a bacteria starts the infection, the macrophages are there to basically engulf and lyse up those cells. So the macrophages are there to pack them out. What also happens during this time is the capillaries dilate. Histamine is released by cells. Okay, and the capillaries dilate and that histamine dilates the capillaries and in turn makes them more permeable. Because remember, the immune cells are basically residing in most of them are in the bloodstream, so they have to make their way out. So this capillary dilation allows for those blood vessels to become more permeable to allow the immune cells out. Okay, foreign matter will get contained. We'll look at this process, and then because these capillaries are more permeable, more leukocytes can migrate to the area. Okay? They're going to have this chemical basically trail that recruits these leukocytes to migrate out to the area of infection. Right? And then finally the leukocytes can come through and clear the infection, right? And then we can remove the inflammation. Okay, so let's look at these processes. We're going to look at this process in step-by-step manner here. All right, so let's look at inflammation. All right, so looking at the first part of the inflammation event, you get tissue injury, you get a cut. Okay, and that cut allows access to these, let's just call them bacteria in this case, allows bacteria to get in. What's going to happen is those phagocytes, okay, those macrophages that are in the tissue around this area will engulf that bacteria, engulf them and break them down. Okay? That's triggers phagocytosis and also secretes products to trigger subsequent steps. So cytokines can be released. Okay, those are the cytokines, those secretions to induce further action. Okay, and here is the blood vessel. Okay, the capillary bed. You see not a lot of space in between, but let's see what happens when our inflammation takes place. Okay, so those cytokines are out there, and we're going to induce cells to secrete histamine. Okay, histamine is going to cause dilation and increase the permeability, the openings between those endothelial cells that are going to allow fluid and allow this increased blood flow, more permeability. Right, this is why you get that redness. Okay, you get that dilation and that permeability. You get more fluid out. Okay, movement of proteins out, and that is what you think of as an inflammation. You get that redness, that heat, also edema, and some pain there. Those classic thoughts when you think of inflammation. Those are induced by that histamine release that is going to increase dilation of the vessel and also increase permeability to allow those substances out into the tissue. Okay, and that's why you get that swelling in that region. Okay, because these fluids and proteins are coming out. Right, so then next, okay, you get clotting. You get those clotting factors. Those you already learned in the blood. You get those platelets coming out. Okay, to induce clotting to close off the site to not allow more bacteria into the tissue. And clot the tissue and prevent more influx of, say, our bacteria, and we get that scab coming out. Then we get these bacteria contained with some phagocyte. We get those diapetus. Diapetus is, you can see the squeezing of these white blood cells. Okay, the white blood cells, they get brought. Okay, they're following cytokines. Okay, and they follow through what's called chemotaxis. There is a chemical signal coming from this inflammation site, okay, infection site, that draws these leukocytes. And it's kind of a cool process to watch. They actually kind of tumble down the blood vessels here, and they're sticky, and then they stick. They get attachment, and then you get that diapetus. Diapetus is this movement through, okay, this squeezing of the white blood cells, the leukocytes, through that capillary wall. And then they can get in, okay, proliferate and migrate, okay, and then finally they are going to clear the foreign particles. They're going to clear everything up, and that site had that scab. Now it's healed, okay, and we're free of invaders. We've cleaned the site off, but that is what is the process taking place during inflammation. So what that redness comes from, mainly that histamine, but all these other steps are taking place to basically prevent that influx of those pathogens. So let's look at that process, that initial phagocytosis. Okay, in phagocytosis, you get those basically attachment of whatever foreign body it is. You get those pseudopods that are moving around to engulf whatever foreign pathogen that is. You get the pseudopods moving around, and eventually you get what's called the phagosome, this vesicle filled with those foreign bodies. Okay, you have lysosomes in there. Lysosomes contain enzymes that are going to basically chop up proteins, chop up whatever is in this phagosome. Okay, so you can see the phagosome gets merged with the lysosome. Okay, and okay, the lysosome is going to chop up whatever is in the phagosome. Okay, so we get these enzymes, and we get this bacterial debris. So these enzymes also, besides the lysosome chopping it up, the enzymes are going to chop it up even more, the debris. And finally, we have this vesicle full of just remnants of that pathogen, and you get exocytosis by the phagosome. Okay, so this is what's taking place. This is basically these Pac-Mans. More than Pac-Mans, they pack them. They basically gulp them up, but they also break down the components to neutralize them, right, and then release them. This is what's happening, taking place in those phagocytes, that phagocytosis. And those phagocytes are part of the innate. They are basically non-specific for what they're targeting. They're targeting not a specific pathogen, but a foreign pathogen in the body. Similar to the natural killer cells. And I believe, I don't know why this was in here. This was taken from actually one of the books line, but they had specific immune response. Natural killers are part of the innate, the non-specific. Okay, we will see the T cells. Okay, the natural killers basically their function is they are one of the first initial responses to infected cells. Okay, so they can attack infected cells. They can actually attack cancer cells too. Okay, but what they do is they have these receptors that give recognition to the foreign body, and they can release substances. Okay, these cytotoxic granular release that will go and lyse the infected or target cell. Okay, so the natural killer cells recognize, hey, this is an infected cell, foreign cell. They can identify viruses or cells infected by viruses, all right, and they basically produce or release what's called these perforins. They're going to perforate the membrane of the target cell and cause lysing of them. Okay? But again, these are innate. These are early defense. So when that coronavirus first comes in, the natural killer cells may be the first online to start attacking the cells. Okay, but we'll see this innate defense is not enough, and so we're going to induce those lymphocytes. Okay, we're going to induce that specific immune response, and this is part of the innate. They're not actually going after a specific pathogen. They are going after cells that they know are infected, but not by a specific pathogen. Okay. All right. So when the non-specific or innate is not enough to clear a certain pathogen, that is when the specific or adaptive immunity comes into play. Again, it is the B and T lymphocytes that are involved in this specific immune response. Okay. And specific means that they are going after a specific pathogen. Okay. And use our example of coronavirus. All right, there will be B and T cells that are activated they will only be activated by coronavirus. It won't be these T and B cells, these specific cells won't be activated by a polio virus or a chickenpox virus. They will be activated by the coronavirus. All right, and what makes them specific is, you can see this is the B cell. It has this receptor on the membrane, and T cells have a receptor for an antigen. Okay, an antigen is basically certain pathogens have certain markers, okay, surface markers that are called antigens. Okay, these are usually proteins or glycoproteins on the surface that are specific for a certain pathogen. All right, so coronavirus would have a certain antigen on the cell surface of the virus. Poliovirus, it would have a different antigen. Okay, and in these antigens are specific regions called epitopes. Epitopes in which these antigen binding receptors will bind to. Okay, and so again, this is specific for a certain pathogen. This receptor here will only bind to the antigen of, if this was a B cell that was for coronavirus, this antigen binding site will be specific for an antigen that is on the coronavirus. Okay, same with this T cell. This, you see a different receptor, but again, the antigen binding site will be specific for an epitope for the antigen on the coronavirus. Okay, for poliovirus, this antigen binding site will bind differently, would bind to an antigen that was specific to polio. So these cells, these B and T cells, are specific for the certain pathogen. Right? Therefore, it is specific immune response. Right? And so for the B lymphocytes, okay, B lymphocytes are going to be called humoral. They induce humoral immunity. Humoral meaning in the blood. Okay? And their job is going to be to secrete antibodies. These antibodies can bind to specific antigens. Again, antigens that are specific for whatever pathogen. Okay? So if these B cells, there are those receptors with the antigen binding sites, right? If they come in contact with that specific pathogen, we'll just say it's an antigen from coronavirus, okay, that will activate these B lymphocytes. These B lymphocytes, okay, that activation, that binding of the antigen to the receptor induces activation that will cause the cells to proliferate, okay, to divide, to create more B cells, and will cause them to differentiate, right? Some will differentiate into what we call plasma cells or effector cells. These will be the cells that are out there during the initial immune response, all right? Going in for the specific fighting. Their job is basically to secrete tons of antibody, and again, these antibodies will bind to the antigen on, if this is a B cell for coronavirus, these antibodies would be for the antigen on coronavirus, and these antibodies would bind to the coronavirus molecule. Okay, we will see what effects this binding of antibodies have. There are multiple effects that can take place, but basically the B lymphocyte's job is to secrete those antibodies. Okay, there are also cells that get differentiated to memory B cells. This is important because these cells are available, right, and ready to go if there was to be a second infection by the, say, coronavirus. Okay, and this is important because this is what we're saying with those antibodies. If we have the antibodies, we know these B memory cells are here, and what these memory cells allow is for us to induce a much quicker and more potent response if we see a pathogen for a second time. Okay, so this initial response would take close to a week to start inducing, start fighting that specific pathogen. Whereas if we have the memory B cells, we've seen the pathogen, our immune system is ready to fight much quicker and much more potent if we just see this a second time. Okay, we can get rid of and neutralize that pathogen much quicker if we see it a second time due to these effects we see with the memory B cells. Okay, we will see this also with the T cells. T cells have a memory also. So here's looking at that secondary immune response, how rapid and how much more potent. Okay, you can see antibody concentrations. We first see the pathogen. You first get coronavirus. It takes close to a week and a half to start getting increased antibody. All right, by this time, the virus can have replicated many times and infected many cells along the way, along this 10-day period, and we get this just small antibody to fight off that specific pathogen. Okay, so what they're thinking, although it's still unclear on whether there will be immunity to the coronavirus, but in most cases, when you have those memory B cells around, your secondary response, if you see, okay, you get a second exposure to coronavirus. Instead of taking 10, 11 days to start up your antibody response, it is much quicker. Around 3 or 4 days, you start getting this antibody response, and it is much more robust. So this allows you to neutralize that virus much quicker and prevent it from taking hold to many of the cells. So it allows you immunity in which you can fight off the virus before it takes hold in many cells of the body. So that is what that secondary response is. Okay, and that's what an immunity basically. This allows you to have immunity because you're able to attack, get rid of the virus before it takes hold in the body. And so that's what they're looking for the coronavirus. They're looking for these antibodies, because if you've had the antibodies already, that means you've had an infection or you've had the coronavirus, and they're assuming that this would take place if you saw it a second time. This is the gist of also vaccines. Okay, vaccines basically are inducing, like you've seen the virus or seen whatever pathogen the vaccine is for, you've seen it once, and it's inducing your body to be able to induce this if it actually saw the true virus. So how do the antibodies operate? Several things they do. You can see here along the continuum, but basically they can help neutralize. They bind to, if this coronavirus, this would be antivirus around that coronavirus. Okay, they can effectively ability to infect the host. So remember, the immune or the virus has to get inside the cells. If they're bound with all these antibodies, that's going to inhibit their ability to get in and to infect the host cell to start using the machinery to reproduce themselves. Okay, agglutination. Okay, agglutination is these antibodies stick and will bind to two different molecules, and this can cause glomming up. Agglutination. You've seen agglutination when we did the red blood cells, right? The red blood cells would agglutinate if they were bound to the antibodies. Okay, so they aggregate. This prevents pathogen from doing its normal course. Opsonation is, you can see here, so the antibodies can't really break down or kill off whatever pathogen is, but what they can do is they can mark, all right? They can mark the pathogen. The antibodies mark the pathogen because the antibody can bind to both the antigen and to the phagocytic cell, which can engulf phagocytose. Okay, so it induces phagocytosis and basically breakdown of the pathogen. And then the complement system we didn't get into, but it is basically the antibodies can induce this complement activation, and the complement activation is basically movement of these complement proteins, but ultimately the activation of these complement system causes the lysing of the pathogen. Okay, so antibodies can activate the complement system. All right, and it also can enhance and natural killer cell activity. Okay, and mark the cells to induce the natural killers to come in and to get those preferins and lyse the cells. Okay, so the antibodies aren't there. They don't actually form the function of neutralizing or getting rid of but they can induce those effects. They can neutralize through their functions, but the lysing actually is the antibodies are just there to induce other activity that can basically cause the lysings of the cells. All right, so let's look at the T lymphocytes. All right, and their response is cell-mediated immunity. remember, the T lymphocytes are actually going to, instead of actually inducing destruction of the pathogens, what the antibodies do, right? They mark the actual pathogen. The T cells are going to actually go after the cells that are infected with the pathogen, right? In this case, say for our coronavirus example, they're going to go and attack the cells that are infected with the coronavirus and try to prevent that virus from replicating more. Okay, there are 3 types T cells. All right, there are cytotoxic. These are going to be the ones kind of the front line of the military or the immune cells. They are the front line defense. They're actually the ones that are going to go out and break down the cells. There are the helper T cells. Okay. These are ones that are kind of the coordinators. They're the generals of the immune system. Okay, these are important players because they're actually going to help induce B cells also and other cells. So they help coordinate the whole immune response. So these are important cells. Right. And then the regulatory, they help keep the immune system in check, make sure it doesn't go overboard and so forth. Okay, we're going to look at these two and the activation of these two and kind of their effects on the immune response. Okay, before we get into that, we have to talk about MHC molecules. So any nucleated cell in your body produces these MHC molecules. These are kind of like markers of self. They're telling, because remember the immune system. The immune system can go out, the T cells are going out and basically attacking the actual cells of the body, the ones that are infected with the virus. Okay, but what the body needs to know are the immune cells. Do you want your immune cells just going around haphazardly, going around and attacking your actual cells, your functional, healthy cells? No. So these are kind of the markers. These MHC molecules tell the immune cells, hey, I'm one of us. Okay, it's a flag saying, hey, we're on the same team, basically. But these molecules are at the membrane, and the T cells are going to have receptors that can bind to these MHC molecules. Okay, they are on surface of all nucleated cells, at least the class 1 are. For the class 2, these are on macrophages, activated B cells, so the immune cells have the class 2 MHC. Okay, but again, these are just markers on the cells saying, hey, I'm one of us. I'm part of our body. Okay, they are called self markers. Marks the body as self. Marks the cell as on the same team, basically, or in the same army. Okay, they are unique for each individual. Each individual has a different self marker. This is where transplants come into play, because if the recipient has a certain MHC class, right, your immune system knows itself because your cells have a specific MHC class molecule. What happens if you put in a donor tissue and that donor tissue has a different marker? Is that marker the same? No, your immune system the recipient's immune system wouldn't recognize that tissue as itself. So it would say, hey, this is a foreign organism. This has got an antigen that doesn't look like what I know as myself, and would attack the actual tissue, the organ tissue, okay, the donor tissue. So that's why they try to match this MHC They're trying to match the donors. They're trying to match these molecules as close as possible between the recipient and the donor. Okay, because this is what's marking the tissues as itself. Okay, so the T cells are going to use what these MHC molecules can also do is bind to viral molecules, pathogen molecules, and present them out. Okay, and remember those molecules have, those viruses have antigens to them. So those MHC can present the antigen out here, and now the T cell can look and say, hey, this is a viral pathogen. So let's see how this takes place with our T cells. Okay, we're going to first look at our cytotoxic T cells. Okay, here is the virus infected cell. Here are the viruses. Okay, fragments of the viruses can be presented by that MHC one molecule. Okay, so now the antigen is shown on the outside. Okay, this tells the T cell, hey, this cell is infected with a foreign antigen. Okay, and a cytotoxic, okay, these are the frontline forces. These are the ones that are actually going to induce lysing of the infected cell. So this binding here, this binding of the receptor, okay, this receptor that is specific for this antigen, okay, activates a cytotoxic T cell. The cytotoxic T cell, when activated, secretes proteins that are going to induce the lysing of, this virus-infected cell. Okay, so that's how the T cells go about. But remember, just like B cells, it is specific because of this receptor binding here. If this was T cell for coronavirus, right, it would only bind, and this virus, this infected cell was coronavirus, it would bind. But if this was a cell that was infected, say if you had polio, this T cell would not bind to here. You would have a T cell that would be specific for poliovirus that would bind instead and induce this response. Okay, so again, this T cell, the lymphocyte response, immune response, is specific for a certain pathogen. Okay. So activation of the helper T cells, pretty similar to the cytotoxic T cells, except for they are going to get the antigen presented on either a macrophage or dendritic cells. So remember macrophages, we didn't talk about dendritic cells, but they will phagocytose certain viruses and then break them down, but then they basically present that virus antigen fragment on their surface, okay, and they present it to, in this case, the helper T cell. The helper T cell, I won't get too specific on the CD4 and CD8, but they will only respond to, you can see it's a class 2 MHC, where the other one was a class 1. Okay, so they only respond, their receptors will only bind to this. They wouldn't bind to the class 1 from the virus infected cell, so they only respond to those that are on the macrophage. So those other immune cells, they present the virus to activate the helper T cells. Okay, the helper T cells, and differentiate, they form memory cells. Again, remember, we're trying to, for the secondary response, we get a more rapid action. We saw it with the B cells. We were going to also have a more rapid action with the T cells on a secondary infection. Okay, these helper T cells, when activated, will release cytokines. Those are the molecules that are going to induce immune response, going to activate more cells and stimulate and regulate the immune response. Okay, they're also going to So they're going to have an overall effect, and they're basically kind of the coordinators of the immune response. They help coordinate the B cells and T cells and coordinate the response. These are the ones, these are important because they're the coordinators. Without them, the immune response lacks coordination and will not be activated fully. So these are important cells. The helper T cells, these are the cells that are infected, right? You've heard of HIV, goes after the immune system, and these are the cells that they are infecting. They're infecting the helper T cells. So that has a very drastic response on the immune response since these are the coordinators. Okay, so HIV, HIV gains access to helper T cells. So this, coronavirus, the cells that the virus would go after are those of the respiratory tract. Here, HIV, the cells that they infect or gain access to are these helper T cells. Okay, so that's why HIV basically destroys the immune response. All right. So one last thing, we're going to look at generating immunity. Since this is what's all in the news, we're talking about looking for the antibody test for coronavirus, because when you have that initial response, you should be able to have immunity where you have that secondary response. It is not always the case, and there's the World Health Organization saying that might not be the case with coronavirus. We're hoping it is, because those that are infected with the initial response would have that built up secondary response. So how do we get immunity? Okay, we can do two ways. We can do active or passive. Active involves, in the case getting the coronavirus, you would have that immunity for that secondary, you would have that ramped up secondary response. Okay, the other way to induce active immunity, active immunity is getting your immune system ramped up so you have that secondary immune response, is through vaccines. So vaccines, basically you're making the immune system act as if they've seen a certain antigen for a certain virus or bacteria. All right, sometimes you can dampen down the virus, or you can just present parts of the antigen in the vaccine, but basically you would inject the antigens in and you would induce that initial immune response. So if you induce initial immune response, you're going to have those memory B and T cells, so you can have that ramped up secondary response. So that is what you're doing with the vaccine. You're basically mimicking the effect you would see if the person actually saw the pathogen but not actually giving him the actual virus or bacteria, just presenting the antigen in the way of the vaccine. Okay, so that's what they're working on now too with coronaviruses. They're trying to work on a vaccine that will induce this active immunity. The other way is passive immunity, and this is something they are using right now, is administering just the antibodies. So not having the immune response be ready to respond to a secondary response, is just giving them the antibodies, okay? Injecting the antibodies into the bloodstream, okay? This does not induce immunity, so it doesn't induce where you would have, if you saw the virus again, you wouldn't have that secondary response. This is just trying to help the immune system at the present time by giving them the antibodies. And they have been doing that recently with coronavirus, is people that they found that were infected and have the antibodies, they can take the person's blood, take the antibodies out, and inject the antibodies into somebody that is suffering from the virus right now. So they have been doing that. I know in New York and probably here in California and other states, they are starting to get blood from people that have been infected that have those antibodies, and then injecting those antibodies into somebody that's severely affected by coronavirus, and hopefully helping their immune system overcome the virus. All right, so that is it for immune system, and this is it for exam 4. So the material for exam 4 will be all those on cardiovascular and then the immune system here. Alrighty.